All right. Vertex form of quadratics. So we're used to this form. Y equals ax squared plus bx plus c. Then I'm going to show you another form. It's like this. Y equals a x minus h squared plus k. So I want to point out one thing. A is the same. Sorry, I want to point out two things. A is the same. And then the other thing is the vertex is h comma k. So think about how nice this is. How do we find the vertex back in this form?
2a over
Yeah, first, just to get the x part, it was negative b over 2a. Then, to get the y, we had to plug in, right, what we found for x into all of this, right? This is way more complicated than this. And so you can imagine this form is really useful. Kind of like slope-intercept form is really useful for graphing lines. It's really going to make our graphing process a lot simpler. Okay? Yeah?
Will they give you what the HK number?
Yeah, so let's give an example of this form. I want to start off with something simple, but you may go, wait a second, when you see this. So x minus 1 plus 2. So why are you maybe going, wait a minute? Because what's, yeah.
That was kind of what we had last time.
Okay. And also, look at this. Yeah, there's nothing in front of the parentheses. So what is A?
It's a 1.
Yeah, so in this case, A equals 1. And I could write a 1 in there if I wanted to, but it's unnecessary. So if there's nothing there, A is 1. Alright, so to graph this, watch how simple this is. My vertex is 1, comma, 2.
Oh, this is.
Remember, it's the negative of this, and it's exactly this. Now the way that I remember this is if we plugged 1 in for x, this whole thing would become 0. And we would just have the 2 left. Okay? So the x part of the vertex is designed to make this go to 0. And the y part is whatever's left over here. So my vertex is just 1, comma 2. There's my vertex. And then I just use standard parabola guide because A is 1. So we're going to go over 1, up 1, over 2, up 1, 2, 3, 4. Something like 5 points is enough. So after getting the vertex, the process is the same as what we're used to. And that's vertex. That's graphing vertex. Let's look at some more complicated examples. Yeah.
How do you get the 1 to be positive? Because
So remember, the form says minus h,
Oh yeah.
right? So it's whatever x would be that would make this whole thing become 0. Right? So, can I erase this? Hooah. So what if I had this? Y equals 3 x minus 2 squared plus anticipating what this is gonna look like by drawing it like this. Alright, what's my vertex here? H is -2 here. I mean, it says -2 here, so H is the opposite of that. Yeah.
2, 3.
2 and then 3, exactly. My vertex is 2, 3. If I plug 2 in for x, I would have 2 minus 2. This whole thing would become 0, leaving 3 for y. Alright, so I'm going to go 1, 2, 1, 2, 3. What do I do next? If I go over 1, how many do I have to go up or down?
So for 3, you'd have to go over 1 up 3.
Very nice. Over 1 up. 1, 2, 3.
I also have a question.
Go for it.
So, is the x just pretty much useless since we take the k and the h and the k, and we use that as the vertex? What is the x used for? If that made sense, I don't think it did.
Well, this is an x coordinate, right? So,
Yeah, but I mean,
last night on your homework, what you had to do was plug in 2 for x, and then you would find that 3 was left, right? So if you use a t-chart, if you were to use a t-chart to graph this, start with x and then go to y. So if I found when x is 2, what is y? It would be y equals 3. I'm saying that x is 2, so I have 2 minus 2 squared plus 3. And then I have to remember order of operations to solve this, right? Parentheses. So y equals 3 times 2 minus 2 is 0 squared plus 3. 0 squared is still 0. So that's my exponents. Multiplication. 3 times 0 is 0 plus 3. 0 plus 3, so we're on to the last part of PEMDAS. It's just 3.
Okay,
So
so
y
it's-
equals 3. So I could still solve this by finding x's and y's and all that sort of thing. It's just that what I'm teaching you is now the shortcut. This is the shortcut. If you have something in this form, right, we know this is our x coordinate of our vertex. This is our y coordinate of our vertex. Does that make sense? Yeah, it's much simpler than when we had to go back here and plug things in for x in order to get y. It's easier. It almost seems like, well, this stuff doesn't even matter, right? Okay. So let's just use our shortcut. So we found that our vertex is 2, 3. We went over 1, up 3. If I go over 2, how many do I have to go up? 2, up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. Somewhere right around there. So we have a really steep parabola. A really narrow, skinny parabola guy. Okay. Questions about that? So that's with A. What about if we had what if we had something even a little different? Y equals negative 1/2 x minus 2 squared plus 5. Let's try this one. So what did I change? If you look at this, I changed the A, yeah. I mean, I changed these two, but this is still negative, this is still positive. The a is now a fraction, and it's now negative. So as we graph this, I'm going to start out with our vertex, which is, what's our vertex? 2, 5. So I go over 2, up 5. And then I look at a and I say, okay, a is negative 1/2. So if I go over 1, I'm going to go down 1/2. Somewhere like that. And then if I go over 2, I'm going to go down 2, right? Half of 4. 1, 2, 3, so I said 2 and then I counted all the way to 3. Okay, we're going to go down 2. This is looking a little irregular, but something like this. So it's a shallower, a more bowl-shaped, a wider frown, because I have this fraction. And this should seem really familiar, because we're used to looking at kind of the first thing, A, and that determines the shape of the parabola and the direction. Okay, so there's one other thing that we need to be careful with in vertex form, which is what happens when we start changing around the signs a little bit. So let's say I said x plus 3 squared plus 1. What's my vertex now for this? Yeah, negative 3, 1. Remember, it's whatever makes this go to 0, and then it just leaves this. So it's the opposite of this, and it's exactly this. Sort of like point slope form here. Remember from graphing lines? So our vertex would be negative 3, 1. We would plot that, and then we'd go over 1, up how many? 1 over 2, up 4. Very good. And let's just look at the vertex of some more. What if I had something like this? Y equals x squared minus 9. What's my vertex here? Yeah. Negative 7, negative 9. So the opposite of this. This makes x go to 0, or this x makes the parentheses go to 0. This is what's left over. And in this case, if I plotted that point, I would then go over 1 and up 4, over 2, and up 16 for henceforth. Okay. Graphing parabolas.